Look at any map of the Earth, and north is on top. From the globe in a classroom to the map app on your phone, it is always the same. North up, south down. You've seen it so many times it feels like a law of nature. But carry that map out into space and it falls apart instantly. In the void, there is no ceiling and no floor. No wall with an arrow that says this way is up. So here's the question that is going to pull the floor out from under you. Are we actually lost out here, drifting in a chaos with no directions at all? Or is there some hidden reference, a kind of cosmic north, that we have been ignoring this whole time? The answer is stranger than either option, because it turns out the Earth is traveling through the galaxy, lying almost on its side. The Sun is racing through the Milky Way, tilted at a steep angle, and our entire galaxy is falling, this very moment, towards something we cannot even see. Almost nothing about the way you picture up and down survives contact with the real universe. There really is a direction that counts as down, and you'll not like it because we're already falling toward it. To find a real down, start with the one you trust. For you, standing on Earth, down means one simple thing: toward the center of the planet. Drop anything and it falls that way. That feeling of solid orientation, of a clear up and down, is not built into the universe. It's built by Earth's gravity, and it only works while you're standing on Earth. Step off the planet and that arrow does not just weaken, it loses all meaning. An astronaut floating outside the station is not upside down or straight up. Those words simply stop applying. So if down is just the direction gravity pulls you, then the honest way to find a cosmic down is to ask a bigger question. Forget what pulls you. What is the biggest thing pulling everything around you? Zoom out from Earth to the whole solar system, and the answer is obvious. It's the Sun. The Sun holds about 99.8% of all the mass in the solar system, and everything else, from the planets down to the smallest speck of dust, is constantly falling toward it. You would expect us to have crashed into it long ago. The only reason we have not is that we're also moving sideways, fast, so we keep missing. We're in a permanent state of falling toward the Sun and never arriving. For the solar system, down is the Sun. But here's the first crack in the picture, and it's a strange one. You probably imagine the planets orbiting the Sun like a flat, level dinner plate, sitting upright as it travels. It does not. As the whole solar system flies through the galaxy, that dinner plate is tilted by about 60 degrees. We're not cruising along the galaxy's main road sitting level. We're tipped over at a steep angle, like a carousel that somebody has shoved onto its side, and we ride it that way our entire lives without ever feeling it. So we found it down for the solar system. You might think that settles it, just on a grander scale. Zoom out to the galaxy, find the biggest thing, and there is your real cosmic down. So let's do exactly that. And this is where it stops being a tidy answer and starts being unsettling. The Milky Way is a flat disk, like the solar system, but unimaginably bigger. A few 100 billion stars spinning in a slowly turning platter. So it has a top face and a bottom face, with empty intergalactic space above and below. And our Sun is not sitting still in it. We are orbiting the center of the galaxy at a staggering speed, dragging the whole solar system along a circle so vast that one lap takes more than 200 million years. Just feel that speed for a moment. Our Sun is hauling all of us around the galaxy at roughly 137 miles per second. That is over 490,000 miles per hour, and you do not feel a thing. But the galaxy is not sitting still either, and this is the part that should stop you cold. Our entire galaxy, the whole Milky Way with all its hundreds of billions of stars, is being pulled. Something out there is dragging us, and thousands of other galaxies with us, toward a single point in the sky. We're not just spinning, we're falling. And for our whole galaxy, that direction we are falling is the closest thing to a real cosmic down that exists. So what is down there pulling on an entire galaxy? The thing pulling us has a name that sounds almost too dramatic to be real science. We call it the Great Attractor, and the strangest part is that we have never actually seen it. Back in the late 1970s, astronomers noticed something was wrong. Our galaxy and thousands of neighbors were not drifting with the general expansion of the universe. They were all streaming together in one specific direction, far too fast to be a coincidence. The whole local group of galaxies is being pulled toward one region at about 373 miles per second. That is roughly 1.3 million miles per hour. So why have we never seen what is doing the pulling? Because of a cruel accident of geography. The Great Attractor sits almost directly behind the crowded center of our own galaxy, hidden behind the dense band of stars and dust we see as the Milky Way in the night sky. Astronomers literally call that blocked region the zone of avoidance. The single most important gravitational landmark in our corner of the universe is parked behind the one wall we cannot see through. We can feel it pulling. We mostly cannot look at it. But when astronomers map the motion of thousands of galaxies, tracing not where they are but which way they are flowing, something enormous came into focus. The Great Attractor is not really one object. It is the bottom of a vast gravitational valley, and our galaxy is just one stream of water running down its slope. They mapped the full size of that valley, every galaxy whose flow drains toward the same point, and gave the whole structure a name, Laniakea, a Hawaiian word meaning immense heaven. And the scale of it breaks the mind. Laniakea is the supercluster we live in. It is about 500 million light-years across and contains around 100,000 galaxies, all of them slowly draining toward that same deep point. Think of an unimaginably huge basin, and every drop of water in it is an entire galaxy of billions of stars, all sliding downhill together. On this scale, up and down are no longer about a map or a tilt. They are about the flow. Down is wherever the galaxies are draining, and we are draining with them. So that is it. Down is Laniakea. Down is the Great Attractor. Case closed. Except there's one more twist, and it is the one that quietly takes the whole answer apart again. Because here is something you have probably heard. The universe is expanding. Every distant galaxy is rushing away from every other, the empty space between them stretching larger every second. But wait, if everything is flying apart, how can we also be falling toward the Great Attractor? How can the universe be pulling itself together and tearing itself apart at the same time? The answer is that both are happening at once, and which one wins depends entirely on scale. It's a cosmic tug of war, on the largest scales between superclusters separated by enormous gulfs of empty space. Expansion wins, and everything flies apart. But inside a region like Laniakea, where galaxies are close enough to feel each other, gravity is still strong enough to pull against that expansion and win, dragging everything down toward the valley floor. We're not floating in calm water. We're caught between two opposite tides, gravity hauling us inward, the expansion of space pushing everything outward. And we happen to live in a pocket where gravity, for now, is winning. Which finally brings us back to the question we started with. Is there a real up and down in the universe? The honest scientific answer is no, and also yes. No, there is no absolute cosmic north, no fixed ceiling, no edge of space with an arrow pointing the right way up. Space-time itself has no built-in top or bottom. But also yes, because for us, locked inside this particular pocket of the cosmos, down has a very real meaning. Down is wherever gravity is winning. Down is the direction we are falling. And right at this moment, we are all falling, silently and at over 1 million miles an hour, toward a place we have never even seen. So the next time someone tells you which way is up, you can tell them the truth. In this universe, up is just the direction you have not started falling yet. And if our whole solar system really is riding through the galaxy tilted on its side, that raises an obvious next question. Tilted compared to what exactly? What is the solar system actually leaning against out there? That is exactly where we go next. It's on the screen right now. I'll see you out there in the tilt.